We are going to pick up where we left off on Monday and talk more today about how to implement schema-based instruction for word problem solving for elementary students. So a quick overview of what my plan is for this session. We're going to review the schema identification activity that I asked you to complete at the end of our last session on Monday, since we ran out of time. Then we're going to talk about the schema-based instruction process, how to use an attack strategy, how to reason through word problems that don't have any missing information. And then we'll do a little overview of what guided practice of this process can look like with students before we close up for the day. So what I would like to do first is just go back and review this activity really quickly that we ran out of time for on Monday. Again, what I'm talking about is this activity. It was in your folder, you had a printout. So you were going to read each of these additive word problems and decide which of the 3 additive schema categories they fit into, and then write a new problem for each of the categories. I'm going to watch the chat. The answer queue was in this document for you, so there were no big mysteries here. But as you worked through that activity, did anyone have questions come up, any confusion about how to identify the problems in the 3 different schemas? So again, I'm just watching the chat to see if anyone had any problems, questions, concerns, anything that came up as they did this activity. All right, I'll keep an eye on the chat. I'm not seeing anything yet. There were 4 combined problems, 2 total unknown and 2 part unknown problems. The combined schema or the total schema is typically the easiest of the 3 additive schemas and the one that we recommend you introduce first when you're working through introducing the different schemas to students. So this one is typically not super challenging for anyone to be able to identify. Compare problems, or sometimes these are called difference problems, tend to be the most challenging of the 3 additive schemas for students to learn to identify. So here we had 4 compare problems, 1 difference unknown, 2 smaller amount unknown problems, and 1 bigger amount unknown problems. And then we had 3 change problems. These also tend to be a little bit easier for students to learn the schema and to learn to identify. So we had 1 of each type here, 1 start amount, 1 change amount, and 1 end amount unknown. Okay, I'm still not seeing anything in the chat about questions that came up with this. So I guess we will just forge ahead. Okay, so the schema-based instruction process. Before we jump in to how to teach the process, this is just a really quick overview of what a program of instruction might look like if you're teaching additive schemas to students, either as initial instruction, so maybe starting with 1st or 2nd grade students, or if you're teaching this as remediation for older students. This is like what a potential 16-week plan of instruction might look like. So you would spend your first 2 weeks reviewing pre-skills, basically to get students ready for the word problem instruction. And then you would start with combined schema instruction, spend several weeks on combined instruction, moving across the different problem types, then go to compare schema instruction, and then go to change schema instruction at the end. And then some cumulative review. So this, I like to share this before we jump in, just to make sure everyone has a sense of how involved this type of instruction is. I don't think that you can teach the schemas in a lesson or 2. This is a long process. reasoning is really challenging for students. So it's important to really take time and to really give the intensity of instruction that students need typically to be able to learn to identify the schemas and then learn the problem solving process. So this is just an example, but I like to share this again just to make sure everybody is on the same page about how involved of a process this is for students, how much learning time you need to, and teaching time you need to devote. Okay, so the schema-based instruction problem-solving process has 5 steps. The first step is to use an attack strategy. We're going to talk about the run attack strategy, but there are many actually different attack strategies that you could choose to use that would fit into the process. So we're going to use an attack strategy. Then we're going to move to label the parts in the problem and map information from the problem onto the schema diagram. That's the second step. Then we choose the solution strategy, write an equation and solve, and check your work. So today we're really going to be focusing on the first 2 steps because those are the 2 steps we use in the first phase of schema-based instruction. This is the same information, it's just in text. So we're gonna today look at how we teach an attack strategy, and then we're gonna focus on phase 1 of schema-based instruction. So in phase 1, we're introducing a new schema. Today we're gonna work with the example of the combiner total schema. And then you're gonna use explicit instruction to teach the first 2 steps in the process using problems that have no missing information. So someone on Monday mentioned a colleague talked to them about solving problems that didn't have any numbers in them, no quantities, nothing to solve for. In schema-based instruction, we use problems that don't have any missing information. So all the terms of the problem and the answer or solution are in the story problem already. The reason for that is to take the focus off of solving and to let us focus our energy and attention just on the reasoning process to get started. So it's a similar idea to what someone mentioned about using problems that don't have any numbers in them. Then in phase 2 of schema-based instruction, we work through the whole process. So the reasoning piece in phase 1, and then we actually do solve, write an equation, and check our work. And that's what we'll focus on in our last session. So again, in phase 1 instruction, which is what we're going to talk about today, we're going to use an attack strategy, and then we're going to learn to label the parts of the problem and map the information onto the schema diagram. And again, we're going to do that using example problems that don't have any missing information. This is just a graphic to show what the run attack strategy acronym stands for. Again, this is just one example of an attack strategy. There are many that you can use. If your school uses one already, it's really great if you can be really consistent with this across grades and classrooms, because it's a generalized problem solving strategy that you can apply to any type of problem and at different levels of problem solving. So this is, again, just one example. Run, the R stands for read the problem and retell it in your own words. U is underline the question. N is name the problem type. Name the problem type is where we're going to identify the schema, name the category, the problem category. And of course, students need to be familiar with schemas before you can work through this piece of the strategy. But we're going to go ahead and look at this first. So an attack strategy, really the purpose is just to make sure that students process the problem. It should be easy to remember. Run is three letters, 3 steps, really simple. Like I just mentioned, good attack strategies should span schemas and grade levels, so you don't need to change your attack strategy every time you learn a new type of problem. You can keep using that same attack strategy. It's important to use an attack strategy because a lot of students skip this part of the problem solving process. We talked on Monday about keyword strategy. So if students are just looking for a keyword and then grabbing some numbers and trying to operate, they don't necessarily have to read the problem. They're just scanning for words. They don't necessarily think through what the problem is asking them to be able to retell it in their own words or find the question. So this part of the process really teaches students to slow down, really read and process the problem, take it in to get ready to move on to the steps where they're going to solve. Research shows us that using a attack strategy improves students' word problem solving performance. So again, this is another part of the strategy that's got a strong research support and good evidence. And our first step is to just model the process for students. So that's what we're going to look at here. We have an example problem. This is it would be a combined problem. Jason broke the piñata at his birthday party. He grabbed 3 stickers and 7 candies. How many prizes did he grab? So when you're using an attack strategy, the idea is just to work through these 3 steps, model the 3 steps for students. So what we have on the slide is basically just a sample script of what the teacher and student language would look like using this strategy. So the teacher might say something like, okay, we've got a mix of numbers and words here. It's a word problem. We're going to run through it. First, let's read the problem together and retell it in our own words. Then everyone could read this problem aloud together. And the teacher would say, okay, now let's retell it. Who can tell it in their own words? And hopefully we would have a student who could tell us this problem's about a boy who broke a piñata open at his birthday party. When he broke it, prizes fell out. There were stickers and candies. He grabbed some of each. If you don't have students who are prepared to do this level of retell initially, you can model it for them. Then the teacher would say something like, okay, we read the problem and retold it in our own words. Now you underline the question. What's the problem asking us? What are we being asked to find? And you want students to be able to tell you what we're looking for here. The question is, how many prizes did Jason grab? And then finally, after underlining how many prizes did Jason grab, we're going to name the problem type. Is this a combine, compare, or change problem? So like I mentioned, students are going to have to be familiar with the schemas before they can answer this question. But once they are familiar with the schemas, you want students to take this opportunity to name the problem type. This is a combined schema. You would want to reinforce the definition by asking students how they know that it's a combined schema. And we know the definition is that a combined problem has parts that come together for a total. So again, 2 parts that come together for a total. Okay, so that was a quick introduction of what using the run attack strategy would look like to process a basic combined problem. What we're gonna do here is take about 5 minutes. We're gonna go out into breakout rooms, and someone in the breakout room is going to volunteer to provide a model of how to teach students to use the attack strategy. Again, run, read the problem, underline the question, and name the problem type for the problem that's on the screen here. In May, the shelter took in 19 cats. In June, the shelter took in 22 cats. How many cats did the shelter take in during May and June? So someone's going to volunteer to be the teacher, and you're basically going to work through the same process that I just modeled for you here. The other people in the group should act as the students, right? So we're just doing a little role play, a little practice with how we would model using the strategy to process the problem here on the screen about the shelter cats. Does anyone have any questions about the activity before I send you to breakout rooms? Okay, I'm not seeing anything coming up in the chat. I'll keep an eye on it for a moment here. I'm going to send you into breakout rooms. Again, we're looking for one person in the room to volunteer to be the teacher. Everyone else is going to act as students. And you're going to use the run attack strategy for the problem up on the screen here. I will, let's see, we want 4 or 5 people in the rooms. I'm going to visit the rooms as you're working. Okay, I'm going to set those rooms now. I joined group 1. I wanted to keep us moving, so I hope I didn't cut your groups off before you were finished chatting. But when the group I was working with wrapped up, I thought we should head back. So did any questions come up using the attack strategy? I'll watch the chat and see if anyone has any questions. I just want to reiterate a couple of points. First, the attack strategy really is about just slowing down and processing the problem. So we want students to read the problem. We also want students to be able to retell it in their own words. So often when we ask students to retell in their own words, they'll read the problem back to us. If they're good readers, they'll just read the problem back. Right? And that's not what we want. We want students to be able to tell us in their own words what's happening in that problem. And then when we get to the point of being able to name the problem type, we want to really reiterate the definition of that schema. So in this case, this was a combined problem. We want to say, okay, we know this is a combined problem because there are 2 parts, the cats the shelter took in May and the cats the shelter took in June. And we're combining those 2 parts for a total, right? So when we're naming the problem type, we want to make sure we're reiterating the definition of the schema. All right, so I'm checking the chat. Say, yeah, we felt it's important to find a common attack strategy across grade levels and classrooms so that students have continued practicing using it. That's a great point. This one, run, is really simple in general. And students could start using this in 1st grade and they could still be using this attack strategy in 5th grade. They could still be using this attack strategy in middle school. There's no reason that this would have to change because it's so general and so simple. And if students are learning it in 1st or 2nd grade, they can carry that with them and you're not reteaching or relearning something new, reinventing the wheel every year. Students learn this and then they take it with them. So that's a really great point. Okay, I don't see any more questions, so we'll just forge ahead here. Does anyone have an attack strategy that their school uses that they really like, one that they would recommend? I'm just watching the chat. One I've seen schools use, another one I've seen schools use is UPS check. People familiar with that one? Understand the problem, plan, solve, and check. That's another very simple, very straightforward, generalizable one that I also like a lot. All right, I'm not seeing anything pop up, so we'll keep moving here. All right, phase 1 of the SBI process. So once students know the attack strategy and they have some of those pre-skills they need to solve, like just basic computation skills, we're ready to start phase 1 instruction. So we're going to introduce the new schema. And then we're going to teach the first 2 steps using problems, again, that don't have any missing information. So there are numbers there, but no missing information. So again, this is where we're focused now, the first 2 steps in the SBI process, and we're using problems with no missing information. We're going to introduce the schema, teach the definition, the gesture, and the graphic organizer and equation first. So this is where I recommend using these FAIR models that we got a peek at yesterday. We're going to spend maybe 1 lesson, maybe 2 lessons, just covering this basic information about what the schema is. So in the combined schema, we have total missing problems, where we put two parts together for a total. That's our definition. We can teach the definition with the gesture. Again, we've got one part, a second part, and those parts come together for a total. We have an example problem here of a total missing problem. Emily saw 4 blue jays and 5 cardinals. How many birds did she see? So we've got the parts, the blue jays and the cardinals. What's missing? The total number of birds. We've got our graphic organizer with our equation under it. And the solution strategy is to add the parts to find the total. Again, the combined schema is our simplest schema. So this is where we start. This is the filled in graphic organizer. So as you introduce this schema to students, you could have them fill in their copy of the graphic organizer. You could create the class chart of somebody is just remembering a problem solving strategy they've used called CUBE. I'm not sure what that one is, but if you want to type what the acronym stands for in the notes so that everyone can see it, that would be great. So, like I was saying, you want to spend 1 to maybe 3 lessons introducing the schema and getting these graphic organizers filled out so students have this as a reference. This is an example video of what it looks like to introduce the total schema. This is like a lesson demo. This is a pretty long video, so we're not going to watch it here together, but I dropped it in the presentation so that you can use it as a reference later if you like. So after you've introduced to the schema, in this case, the combined schema, you filled out your graphic organizer with students. They know the definition. They know what the graphic organizer looks like. Then your next step is to teach students to identify the problem type, label problems, and map information onto the graphic organizer. Again, we're using problems that don't have any missing information. So what I have here for you is a sample script of what this could look like in practice. So the problem we have here is Anne has 3 apples and 2 oranges. She has 5 pieces of fruit. So there's no question here, right? There's no missing information. This is just a total story. We've got 2 parts and a total, all given to us, all in this story. So the teacher would say something like what the script says at the bottom when you're just introducing the combined schema and you're teaching students how to reason through this problem to identify it as a combined problem. So today we're going to keep learning about our new problem type called combine. In combined problems, there are 2 parts that come together for a total. I'm going to start by reading the first story and retelling it in my own words. Anne has 3 apples and 2 oranges. She has 5 pieces of fruit. In the story, there's a girl named Anne. She has 2 different kinds of fruit. She has some apples. She has some oranges. And I can tell this is a combined story because there are 2 smaller parts, the apples and the oranges, that come together for a total, the 5 pieces of fruit. So that's me as the teacher modeling, narrating my thought process, how I'm reasoning through this story to identify it as a combined story. The next step, after going through that initial process of explaining why it's a combined story, is to map the information from the problem onto the graphic organizer, or the schema diagram. So we would say something like, typically the total tells about all the things in the problem. In this story, fruit describes the total because apples and oranges are both fruit. So I will label 5 pieces of fruit in the story with a T for total. And next, I'll transfer that information from the story to the diagram. 5 pieces of fruit is the total, so I'll write 5 in the total box. Let's also write fruit next to the total box in the diagram to label our total. Right now we need to find the parts. What are the parts in this story? There are 2 parts, apples and oranges. In the sentence, Anne had 3 apples and 2 oranges, I'm going to label apples with P1 for part 1, and I'll label oranges P2 for part 2. Next, I'll transfer that information from the story to the diagram. So in the box for part 1, I'll write 3 for 3 apples, and in the box for part 2, I'll write 2 for 2 oranges. Now we'll read the story one more time and check our diagram. The story is 2 parts, 3 apples and 2 oranges, 3 apples, 2 oranges that come together for a total of 5 pieces of fruit. Do the gesture with me as we explain the problem one more time. So this is a combined problem. There are 2 parts, 3 apples, 2 oranges. We put them together for 5 pieces of fruit, a total of 5 pieces of fruit. Okay, so that was just a really quick model of what this looks like, this process looks like, of first processing the problem, reasoning, explaining your reasoning so that students understand why we're going to identify this problem as a combined problem, and then how we reinforce that as we work through the process of taking the information from the story and plugging it into the graphic organizer. So, and again, at this phase, when we're first introducing the schema, we're using problems that don't have any missing information. All the information is there. So we're taking all of the processing power and attention and working memory that students have got to devote to this process and focusing on the reasoning and getting ourselves set up to solve. We don't want students trying to jump ahead and just grab numbers and solve on their own. We want them to really focus their attention and energy on the reasoning part of the problem solving process. So what we're gonna do is, again, head into breakout groups to do a little bit more practice with this part of the process. So modeling problem identification and then mapping information onto the diagram. I'm going to send you into breakout rooms again. This time I'm going to send you into groups that are rooms with just 2 people, so that one partner will have an opportunity to work through that process or model the process with the first problem there. Emily saw 4 blue jays and 5 cardinals. Emily saw 9 birds. And the second partner can model the process with the problem about Farmer Joe. So your problems are here. Again, I'm going to send you into breakout rooms with just one other person. And you're going to take turns working through the process that I just modeled here of, first identifying the problem type. So you're going to retell the story, explain why it's a combined story. What are the parts? What is the total? How do you know? And then you're going to take the information from the story and map it into the diagram, again, explaining how do you know what the total is, how do you know what the parts are as you work through. Okay, so any questions? I'm going to watch the chat. So someone saying their microphone isn't working. Okay, so maybe in that case, I'm going to go ahead and just send people into rooms with one other partner. Okay, it looks like everybody is back, or almost everybody is back. And I'm sharing my screen again here. So I want to take a minute just to reflect. I got to visit a couple of rooms this time, and I heard some really interesting conversation about how this process of using problems that don't have any missing information, spending time to identify the problem type and then map onto the diagram, how that's a little bit different than other approaches that people have used in the past for teaching problem solving. So I'm really interested to hear any reflections you all have on what's challenging about this process and maybe why, or what you think about starting using problems that don't have any missing information. So if anyone has thoughts about either of those things, please type into the chat so I can sort of see what you're thinking after having a chance to spend a little bit of time practicing. All right, so I'm going to keep an eye on the chat here. Something that I heard from a group that I thought was really interesting was that they thought using the graphic organizers was really helpful in giving students more structure for their language and how to restate a problem. So once we plug in part 1, part 2 in total, we can retell the story just by sort of narrating through that graphic organizer, which I think is a really nice idea, because we know students often really struggle with that part of the process, being able to retell in their own words. All right, I'm not seeing anything in the chat. I'm going to keep an eye on it in case anybody is typing. Oh, here's something. I like doing it with no missing info because it helps show the setup of the information in the graphic organizer, and that lets them get a foundation. Yeah, I agree. I think this is a really useful part of the process for students. And no missing information gives students the opportunity to build their confidence, right? So math anxiety is real for a lot of students with disabilities, especially older students who have experienced a lot of frustration over years with math and with word problems. So sometimes when we present a word problem to a student who's got that kind of history, they can just kind of freeze up. And we don't want that, right? So if we give them the problem that has no missing information, there's no problem there, it's just a story. We're starting from a point where we can sort of like get past some of that math anxiety that students have. Also, we don't want students to get preoccupied with trying to solve. We don't want students just racing to get an answer, which is a really common behavior for all of our students. They see a problem, they just want to solve and move on to the next thing. So by giving them all of the information, we're taking away that sort of impulse to just race through, because that's not the point. The point is to talk through the problem, figure out what kind of problem it is, and set up our graphic organizer. That's the work. The work isn't just solving right away. Someone says they really liked the piece, read the story again and check our diagram to make sure they're making the connection. Yeah, that's really important point too. We want students to understand that the information in the organizer came from the story, right? That those pieces are connected. And that's not an automatic connection that a lot of students make, especially if we're doing if we're really supporting them through the process. So we want to take the time to check everything back to make sure that they're seeing that connection, making the connection for themselves. Okay, great. Thank you. Thank you all so much for participating in the comments there. I think those are all really great ideas. All right, and the last piece I have to share here is about how we're going to use explicit instruction to teach the SBI process. So, so far we've been looking at models, teacher modeling, and practicing teacher modeling, but it's really important to think about how we're going to provide practice for students. Again, this tends to be really challenging work for students, so they need a lot of practice to become independent doing this work. So I like to use the TAR framework for guided practice, where you start with tell level prompts, fade to ask, and then fade to remind. If this is familiar to anyone, type a note in the chat. Like I've seen this before, I know this framework, because I don't want to beat a dead horse if this is something that most people are really familiar with already. But this is really just a process of scaffolding practice so that we're providing a lot of support with our first couple of practice problems, and then gradually fading support so that students are becoming more independent over time. Okay, so I'm seeing some not familiars in the chat, which is good. So the TAR framework, TAR, tell is for problems in which we basically baby step students through the solving process. We tell them how to solve and they do it along with us. Once students show some proficiency there, we can fade to ask level prompts, where we're basically asking questions to prompt students through the process. And then once we get proficiency there, we fade to remind level prompts where we basically are just saying, okay, remember what we just did, and you're gonna do some practice problems more independently now, but we're still monitoring. It's not independent practice, it's still guided practice, because we're still monitoring really closely and troubleshooting. So this is a graphic organizer of what this framework can look like. Basically, if students are making mistakes at any part of the framework, we just keep working at that level. We don't fade to the next level. If students are doing well with practice problems at a level, we fade to the next lower level of support. So with guided practice, some really just basic tips. We want to make sure that practice problems are really similar to the problems that we used when we were modeling, and that we're using really consistent language. We also want our practice problems to be really similar in structure across the guided practice levels. So if we give a tell problem that looks like one of the combined problems we just solved, we want to use that same type of problem for ask and remind. So a common mistake I see with guided practice is that teachers will make practice problems more difficult as they're fading support, which can be really tricky for students. We really want to keep problems consistent. Okay, so we're not going to have time for this last activity. I tend to overplan. I think lots of teachers can relate, because we never know how things are going to go, right? So we like to have more material than we need. So for this next activity, basically what I was just going to share with you is an example lesson plan, which I think should be really helpful still if you have time to look at it on your own. It's in the folder. This is what the document looks like. It's called SBI Example Lesson Phase 1. And this is one fully scripted example lesson plan for what a Phase 1 schema-based instruction lesson would look like. And it uses the same example that you saw in the PowerPoint to start with Anne and her fruit. So this should be, this piece will be familiar, and then you'll see the guided practice for students added on to that initial model to see how like this full lesson would look for students. So what I would love for you to do before we come back together for our last part of this series is look over that lesson plan, that example lesson plan, and ask yourself these questions. How does the teacher fade support during guided practice? From tell to ask and from ask to remind level problems. Those are all labeled in the lesson. So that should be easy for you to think through. And then how's the structure of guided practice in that lesson similar to or different from the structure of guided practice in your own lessons or lessons that your partner teaches in math? Just think about similarities and differences if you can. And then when we come back together for the third part of this series, we'll just pick up looking at this example lesson before we move on to phase 2 of schema-based instruction.